All right, when you look at this kite, we have a couple properties that you need to be aware of involving a kite. The diagonals are going to intersect one another at right angles. And again, the diagonal that connects the intersections of the equal sides is going to bisect the other diagonal. So these two lengths will be the same. Okay, so when we look for the area of this kite, if we break this kite into two equal triangles, okay, so I'm just going to outline one of them. Okay, so you can see that this triangle is mirrored across the longer diagonal here to form the kite overall. So if we can find the area of this one triangle, we can then double it and get the total area of our kite. So the area of our kite is really just going to be 2 times this one triangle. Okay, so let's see if we can find the measures for that one triangle. Okay, the base of this triangle is just what we have in this case is our longer diagonal. So we'll call that D1. So here's our base, D1. And since we're dealing with these in terms of diagonals, let's look at the other diagonal of this kite. We'll call it D2. It's just from this whole green segment is our diagonal 2, D2. If we want to find what the height is of this triangle, oops, let me go back to the formula. Okay, so our area formula for a triangle is 1/2 base times height. Okay, therefore, when we look at our diagonals here, the base of our diagonal is D1. The height of this triangle is going to be half of D2. You see that they're two equal pieces. So this half or this height is 1/2 of D2. So if we then multiply 1/2 of D2, what we can do is complete our calculation. The half and the 2 cancel. We have this 1/2 out front, the product of D1 times D2. And so this gives us our area formula for a kite. It's simply going to be 1/2 the product of their diagonals.